of Master the NEC. And in today's episode of Master the NEC, we're going to do a start off of a 7-part series. Okay, so I previously did a video that was 6 hours, 6.5 hours on swimming pools, spas, hot tubs, and whatnot. And the video was lost. It didn't get uploaded. So it's much easier than to me to spend, and I promised people that I would have a webinar of it. And I did have a lot of people watch the webinar. But what happened was something in YouTube's end didn't record the information, and rather than take another 6.5 hours of my day, I said I would start doing it in parts. So over the next couple weeks, I'll do part 1, part 2, part 3, part 4, and so on, and we'll cover it. And maybe that'll break it down a little bit. Some of them won't be as long. Obviously, part 2 is going to be the longer of the ones. So, but the other ones, part 7, hydromassage bathtubs and all, they'll be short. So hopefully you'll be able to follow it. So this is going to be part 1 of a 7-part series, and we'll talk about the basics of swimming pools and those type of things. So hopefully, again, my name is Paul Abernathy. I serve on Code Making Panel 17. I also serve on Code Making Panel 5. I was a former NEMA rep, so I served in those capacities, and I also worked in multiple jurisdictions in Virginia as the engineer 2 for the Inspections and Plan Review Division, or the code supervisor for the City of Alexandria, where I oversaw the electrical division inspectors and all their education and whatnot. So certain different aspects, and I've been an electrical contractor and a master electrician for nearly 30 years. So hopefully I can bring some information to you. I did serve on Mike Holt's 2008 panel when he did his videos for that, for understanding the NEC, and so that was a great experience. So, so I have a little bit of history with it. So hopefully I can teach you something or give you some insight. So today we're going to go over part 1, which is going to basically talk about some of the definitions and some of those aspects in part 1, and then we'll say there'll be a part 2 and a part 3 and whatever, and we'll go through each one of them. So before that, I want to make sure you understand that if you have any questions at any time, feel free to email me at info, that's INFO, at masterthenec.com. Okay, so feel free to do so if you'd like to follow along there. Also visiting our website, you can go to, which incidentally you can get to whether it's masterthenec.org, .net, or .com. Either one of those you can utilize. Emails, though, have to come to the .com address. So hopefully you will be able to get some information out of that, hopefully. So, all right, well, let's get started, get rid of me, and get into our National Electrical Code. All right. So today we're going to present part 1 of Article 680, swimming pools, fountains, and similar installations. Well, as you can see here on the screen, these are swimming pools. Now, this pool right here is a permanently installed. It is in the ground. We'll talk about those nuances as we get through it to try to clarify the differences. But kind of in this part 1, we're going to kind of go over the general information and go from there. Now, 680 is broken down into 7 parts here. And there's the general rules, which we're going to cover today. We have the permanently installed pools, storable pools, spas and hot tubs, fountains, pools and tubs for therapeutic use, and hydromassage bathtubs. And we're going to cover each one of these in depth. We obviously can't cover every single aspect of it, but of course, as you can see, it took me 6.5 hours, so I covered quite a bit of it. So we're going to take it and break it down and hope that each time that YouTube actually records these presentations. If not, we will do one over again as necessary. Hopefully everything's good. And each time we do them, they will be broadcasted live on the Master the NEC website. So these are not edited recordings. These are live. When you see it, if you see it on the website, on our website, that it is live. Okay, it is running. All right, so we kind of want to know what each one of these parts to deal with. So part 1 is the general requirement, and then part 2 is dealing with permanently installed pools. What is a permanently installed pool? A permanently installed swimming pool, wading, immersion, and therapeutic pool are those that are constructed in the ground or partially in the ground, or all others capable of holding water in a depth greater than 42 inches. So that's kind of the general rule there. And all pools installed inside of a building, regardless of the water depth, whether or not served by electrical circuits of any nature. So it doesn't matter whether electricity is to it or not. Okay, so if it's in the ground, partially in the ground, or it's inside of a building, and it's capable of holding water at a depth greater than 42 inches, then it's going to be considered a permanently installed pool. And these are what you have here. This right here is a partially in the ground, so it is still a permanently installed. This one's all in the ground. Here's some indoor ones. Remember we said it doesn't really matter on that. It's all indoors are considered permanently installed pools, and that's what we have here. Here's a pool right here that's actually not a polymeric wall. This is more of a rigid construction. But beyond that, its depth is 48 inches. So since it is beyond 42, it is not designed to break down like a storable pool. In fact, they come in here and weed eat around it, I guess. So these aren't inflatable or a polymeric sidewalls. These are rigid sidewalls. This is with a structural framing members. This is a permanently installed pool by virtue of depth and by virtue of the fact it doesn't meet the storable pool requirement. So what is a storable swimming pool? Storable swimming, wading, and immersion pools, or storable portable pools, spas, or hot tubs, are those that are constructed on, that's a key component, on or above the ground, and are capable of holding water to a maximum depth of 42 inches. So that's a maximum depth of 42 inches. So if it's on or above and it holds only up to 42 inches of water, then we've got a storable pool. Or a pool, spa, or hot tub with non-metallic molded polymeric walls. That's those walls that are out. That also is going to be restricted to up to 42 inches in order to be considered a storable pool. And then, of course, you go on to say inflatable fabric wall, regardless of dimensions. Doesn't matter how deep the pool is at that point. If it's an inflatable fabric wall type of pool, we'll see a picture of one in a minute, then it is a storable pool. And there's the storable pool right there. Now, the one thing to remember in these pools, again, we use an example of this pool here. These are not polymeric walls. I can promise you that. However, this is the rigid support. This is not designed to be broken down. But what I will remind you that, again, if it's a storable pool, it has a maximum depth of 42 inches. If it's a permanently installed pool, it's going to be more than 42 inches. Or if it's in the ground or partially in the ground, it's automatically going to be considered a permanently installed pool. We're going to deal with, as our certain parts that we get to later, we're going to be dealing with spas and hot tubs. So spas and hot tub, what is a spa and hot tub? Well, a hydromassage pool or tub for recreational or therapeutic use, not located in a healthcare facility, designed for immersion of users, and usually having a filter, a heater, a motor-driven blower, what have you. It may be installed indoors or outdoors. It's kind of irrelevant. Obviously, you're going to see later when we talk about outdoor spas or indoor spas, whether or not they're listed for outdoor and some of the applications for their use. But they'll be, it'll be installed indoor, outdoors, on the ground or supporting structure, or in the ground or supporting structure. So it could be actually in the decking material or actually in the patio, if you will. Generally, a spa or hot tub is not designed or intended to have its contents drained and discharged after each use. So that's an important concept here. You're not going to drain these after. These hold hundreds of gallons of water, so we wouldn't get into that. Unlike a hydromassage bathtub, which you would drain every time. We're going to get into spas and hot tubs. There's a difference in packaged units. It's a packaged spa and hot tub equipment assembly. It's a factory fabricated unit. It consists of water circulating, heating, and control equipment. Notice it has heating on it. Again, different than a hydromassage bathtub. On a common base, intended to operate a spa or hot tub. Equipment can include pumps, air blowers, heaters, lights, controls, sanitizer generators, and so forth. That is your packaged unit. So here's your packaged unit here. Sits on the deck, sits on the surface. And here's one that actually is going down through in the structure. Part 5, we're dealing with fountains. We're going to talk about fountains. One thing to remember when we get to fountains, that fountains, ornamental pools, display pools, and reflection pools, the definition does not include drinking fountains, so don't think of fountains and drinking. That you want to deal with 422. You're going to go over to appliances, and they're going to deal with your drinking fountain application. Permanently installed decorative fountains and reflecting pools. Those are constructed in the ground, okay, on the ground, or in a building in such a manner that they're not designed to be disassembled for storage. You know, they're permanent. They're supposed to stay in place, okay? Permanent fountains, you're going to see something that's going to require to deal with 422. That's not what we're talking about here. These are permanent fountains. It doesn't matter whether they're served with the electrical circuit or any nature of that. They're still fountains. These units are primarily constructed for their aesthetic value and are not intended for swimming or wading, obviously. Here's the two examples of two fountains. Now, these fountains have lighting in them, so they do have electricity running to them for the lighting, but not required to do that. All right, and then we're going to deal with pools, tubs, and therapeutic uses. All right, so this is part 6 here. So packaged therapeutic tubs and hydrotherapeutic tank equipment assembly. We will talk about that in brevity when we get to those areas. Basically, they're factory fabricated units consisting of water circulating, heating, and control equipment mounted on a common base. Sounds pretty close to what a normal hot tub would be, right? Intended to operate a therapeutic tub or therapeutic tank. Equipment can include a pump, air blower, heaters, lights, controls, sanitation generators, sanitizer generators, and so forth. Okay, but these are going to be used for therapeutic or hydrotherapeutic use. A self-contained therapeutic tub or hydrotherapeutic tank is a factory fabricated unit consisting of a therapeutic tub or hydrotherapeutic tank with all the water circulating, heating, and controlling integral to the actual unit itself. So it's all built into the unit. So if you have one that has the water, the circulating, and what all that's built into it, then you have a self-contained unit. And that will include pumps, air blowers, heaters, can include lighting controls, sanitation, sanitizer generators, and so forth. Yeah. All right, so here is a unit here that would be an example of the tub, and here's one would be the assembly here. So this one would be packaged assemblies. Hydromassage bathtubs. We'll end up with part 7 is a permanently installed bathtub equipped with a recirculating piping system. That's the plastic piping typically that goes around the bathtub. Pump and the associated equipment. It is designed so as it can accept, circulate, and discharge water on each use. Okay, so it's not designed like a spa in order to keep the water in there. You add chemicals to it. You use it for months at a time. Here you use it, you drain it. Okay, it goes in the house. An apartment, has some jets on it, those type of things, and that's what it's associated. Generally, the hot water for these come from the hot water system. It doesn't come from any type of heater involved. And here's what we're talking about right here. Here's are two examples of that. All right, so we're in part 1. We want to talk about 680.5, ground fault circuit interrupters. So what are we talking about here? Well, here we've got 3 of them. Now, remember later when we get to storable pools, when we have a 15-foot cord, for example, and it has integral GFCI protection. This is one of those that's a self-contained application. But you have circuit breaker type and you have receptacle types. All of them are listed, and they are providing the GFCI protection. Okay. It's important to understand how GFCIs, even the receptacles, are wired. Here an example just to kind of show you the powers coming in, going to the line side of a GFCI, and then you've got the load side of the GFCI that protects all the receptacles downstream. Now, one thing to remember here is even this receptacle, if there was no load side terminations, it still would be protected. This device would be protected, GFCI protected, okay? And it's designed, and you test it here. There's a test and a reset button right on the front of it. But just remember there's a line and a load application here. All right, when we're dealing with grounding, 680.6. 680.6 dealing with grounding, it says electrical equipment. Now, again, one thing to remember is that Article 250 still takes some some important understanding. And it's chapters 1 through 4 are still going to be the general chapters that have to be enforced generally throughout the code. However, 5, 6, and 7 can modify. And in fact, they modify themselves. Now, the one thing that's going to remind you that when you're dealing with grounding in 680, you still have to meet some accordance with 5, 6, and 7 of Article 250. And obviously anything that adds to that in 680. Okay? So you have to remember that. And that can come into play also when we're dealing like in 680.26 with the equipotential bonding grid and all those requirements. Trying to remember that's a bonding component, that's a localized thing. Don't confuse that with the grounding of a structure or electrodes or what. Don't get the two confused. Totally different aspects here. However, you do have equipment that's going to be associated with all of these areas within 680, and there's going to be grounding requirements, most notably equipment grounding applications. So, the code says in 680.6, to just remind you up front, electrical equipment shall be grounded in accordance with Part 5, 6, and 7 of Article 250 and connected by wiring methods of Chapter 3. So they're going to be those that are listed in Chapter 3. It'll be like your rigid, EMT, all those kind of things. Except as modified by this article. So again, 680 can do some modification to those chapter methods. Okay. The following equipment shall be grounded. So now we just have a list of the following equipment that just kind of says, hey man, it's got to be grounded. Now you're going to do this probably through your equipment grounding conductor. So you need to make sure one is present. But we're going to have all these grounding requirements. And you have 1 through 7 here. So now if we have through the wall lighting assemblies, which we talk about later, when we talk about through the wall type of underwater luminaires, we'll get into that. But this says, look, through wall lighting assemblies and underwater luminaires are required to have an equipment grounding conductor. Now, other than the low voltage lighting products listed for the application without a grounding conductor, okay? So those low voltage contact type of values that you're found in 680.2 for that definition, which incidentally, it really deals with 15 volts RMS of sinusoidal AC, 21.2 volts peak for non-sinusoidal AC. All depends on the system you're dealing with. 30 volts of continuous DC. And of course, 12.4 volts peak for DC that is interrupted at a rate of 10 to 20 hertz. So, if you're dealing with one of those type of systems, you're dealing with something where you probably are going to have a separation from a primary to secondary transformer, either through a grounded barrier or double insulated component for that transformer type of setup for that lighting. Okay, that's different. That wouldn't have a grounded conductor needed for that application when you get down to the actual luminaire component. So that that's what it's talking about there. 2, it says all electrical equipment located within 5 feet of the inside wall of the specific body of water, no matter what body of water we're talking about here in the code under 680. If we have that equipment, we want to make sure that we have an equipment grounding conductor run to it so that we have that grounding component. 3, all electrical equipment associated with the recirculating system of the specific body of, or the specified body of water. So whatever circulating equipment, whatever the equipment is, the pumps, whatnot, are going to make sure that you're aware that you have an equipment grounding component in order to connect to that electrical equipment. Okay, trying to keep the bonding component of the equipotential bonding aspect away from our grounding component, because we know that an equipment grounding conductor can serve multifunctions here. It can serve not only a grounding component, but also a bonding component when installed properly. Okay, so keeping that in mind. We got to ground all junction boxes. Transformer or power supply enclosures the supply side of that will be provided with a grounding component. Ground fault circuit interrupters are going to have an equipment grounding conductor run to it, so it's going to have that component. It's going to have that grounding. And then panel boards that are not part of the service and that supply and electrical equipment associated with the specific body of water. So let's say a remote distribution panel for a pool application. That panel board, not the service one, but the feeder from that panel, service panel, to the actual remote distribution panel for that pool, that's going to contain things like branch circuits and whatnot down to the receptacles and what have you. That component between there, you're going to have equipment grounding conductor aspect when you're dealing with those panel boards. Okay, all right. So that's what this is dealing with. Now let's look at 680.7, cord and plug connected equipment. Actually, it's under Part 1, so it's a general requirement. This is going to apply broadly, except for in other than stored pools, which could obviously going to have a longer cord because of their nature. It's going to have an integrated GFCI, whether it's in the end or within 12 inches of the end. But here we're talking about maybe a fixed or stationary equipment that you want to connect with a flexible cord and plug design for removal or disconnection for maintenance or repair. You can do so. The cord can't be more than 3 feet in length. Okay, so we're not talking about storable pools here. We're talking about pump motors, where it's going to be used for a permanently installed, and it's a fixed and stationary type of equipment. In other words, you want to keep it in place. Now, the equipment grounding conductor in this flexible cord is got to be a 12 copper AWG minimum. But if the circuit is actually larger for maybe a motor, a pump, or whatnot, then just remember that it's also going to be sized based on 250.122. And this cord shall terminate into a grounded type plug. Just remember that 12 is the minimum, but it might be larger depending on the overcurrent protected device that's supplying the circuit or supplying to the cord. Okay, so keeping that in mind, so 250.122 does rear its head in here in that familiar table, which sizes the equipment grounding conductor based on the size of the overcurrent protected device supplying power to that circuit. Next, it goes into equipment grounding shall be connected to fixed metal parts of the assembly. Removable parts mounted on or bonded to the fixed metal parts. So you're basically making that connection to the actual fixed metal parts of that assembly. All the removable parts are designed to, when they're mounted onto the assembly, they're bonded to the assembly. If not, you're going to provide some kind of bonding in order to be able to bond all these fixed parts, unless that removable part is totally separable from the assembly. Once it's together with the assembly, then and it's on the assembly, which power is being provided to that assembly, then it has to be in contact with the equipment grounding conductor through the fixed metal parts of that assembly. Here's an example of a pump where the cord in this pump right here is for use in permanent pool applications only, and you'll see that the cord is not over 3 feet long. And here's an example of a cord with an insulated, at least 12 gauge equipment grounding conductor serving a equipment grounding function and a bonding function. Here's a picture of a pool here. This is actually a listed pump. This actually is a listed third party by UL on this one. Notice it says this pump is for use with permanently installed pools only. Do not use it on a storable pool. So that information is right there. That is very beneficial. And you'll notice that it says here that's for above ground pool pumps. So it's, there's some information on there that's going to give you guidance on how you install this and where it's to be used. Obviously, if a cord was used for this, then it's got to be 3 feet or less. Over here, you'll see a typical pump and filter setup for a storable pool, where this is usually about 15 feet or so. And here's the pump, and here's the filtration, and it pumps it through. And so this is designed for those storable type of pools. And it can have a cord longer than 3 feet. All right, let's talk about overhead conductor clearances, 680.8. Now, we have an A, B, and a C. We have the communication systems application here, and we have the network-powered broadband communication, and we have normal power. Okay, the one I'll go to first is B, so we can knock this one out of the way. The code says that communications, radio, and television coaxial cables within the scope of Article 800 through 820 shall be permitted at a height to not less than 10 feet above swimming and wading pools, diving structures, and other observation stands, towers, or platforms. So you have a flat-out 10-foot minimum on these communications, and those that are dealing with 800 through 820 are going to fall in this clearance. So we don't even need figure 680.8 for this application. You need to maintain 10 feet on these applications where they deal, again, in Article 800 through 820. Now, when we're dealing with power cables, we're dealing with figure 680.8, and we're dealing with 680.8 for overhead conductors, notably A. And when we're dealing with network-powered broadband communication systems, we're dealing with the same application here. So we're going to talk about those two together. So 10-foot minimum in all directions for this communication system. And here we have a figure for the network and the power. So let's look at those clearances. All right, the first thing that we want to throw out in those clearances is right here. We're dealing with insulated cables from 0 to 750 volts to ground, okay, which is going to be typically what you're dealing with. But here's the other component. They're supported on and cabled together with a solidly grounded bare messenger or solidly grounded neutral conductor. So if it's a neutral supporting or if it's a bare messenger supporting and it's solidly grounded, if this is your application, here are your clearances. For most utility applications that are coming across the property, this are going to be your clearances. Now, the utility might be there first, so the pool people have to make sure that they're aware of these clearances so they don't construct the pool underneath one of these. Now, if it's some other method than these here, they're all covered over here. And it's all other conductors voltage to ground, and it's 0 to 15,000 volts. You have your clearances over here. So just understand which one you're talking about here. A triplex application that comes down with a supported messenger or a solidly grounded neutral conductor, you're going to be in this area. Anything else, you're going to be in this area. Now, look at this diagram. This diagram is what's in the actual National Electrical Code. And again, all references that we use to the National Electrical Code are for educational purposes only. No monetary value is being placed on this presentation, or any charges are being for this webinar are taking place. All of the information and documentation that's coming on these slides from the National Electrical Code are being done so by a legally purchased copy of the National Electrical Code in my possession with my name attached to it. Okay? Now, here we've got some clearances. So let's look at it. A, clearances in any direction to the water level. Okay, so any direction. Edge of the water surface, base of the diving platform, or permanently anchored raft. And that's A clearances. All right, so here's your clearances here from the water. There you go. That's 22.5 feet. All right, so where else do we got it? Okay, here from the base of the diving platform up 22.5 feet. Now, that's from the diving platform. Now, next we move into clearance from any direction from observation stands, towers, or diving platforms. So now we jump into the diving board aspect, or these observation stand aspects. Here it says any direction, and I'll talk about this vertical limitation. I've got to make sure that I'm maintaining 14.5 feet. Here, 14.5 feet. Here, observation stand, 14.5 feet. As the steps go up, obviously this range is going to go up. Okay, so that's what's required for the observation stand, towers, or diving platforms. Now we're going to get into the horizontal clearances. And again, this goes all the way around the pool. This is just not in this cut section of a pool right here. This goes and encompasses all areas of the pool all around it. Now, horizontal limit of clearances. Notice it says horizontal limit. Measured from the inside wall of the pool. So from right here out. It says this limit shall extend to the outer edge of the structures listed in A and B. So here the observation stand is listed, so it's got to extend all the way out to the end of it. We got a diving board here, and this diving board only extends out 4 feet. So you say, okay, wait a minute, does that mean I have to stop it here? No. You read on, and it also says of this table, but not less than 10 feet. So you still have to go out 10 feet, even though the end of this diving board here, platform, might only be 4 feet. The minimum is going to be 10 feet, or whatever the length of the item that's listed in A and B is. Okay? So that's why you show this one here. Let's say this observation stand was out 15 feet. Well, 10 feet would be back here. Well, obviously we have to extend it all the way out, and then all of these clearances are going to extend out to the end of that. Over here, the same way, you'll notice that everything extends out 10 feet. This might be only 5 feet to here, but it continues on to 10 feet, and then that's the demarcation line here for these clearances. Okay, that's the furthest point. Once you start getting down here, you know, it's different. You're not getting a clearance here. You know, this is the limitation mark. Okay. So hopefully that cleared that up and people understand the clearances over the pool application. All right, 680.10, underground wiring locations shall not be permitted under the pool or within the area extending 5 feet horizontally from the inside wall of the pool. Okay, so no wiring goes within that 5 foot period around the pool. Nothing. Now, what about if I've got some lighting? Obviously, I do. What if I have some wet niches, which are not required to have them, but if I did have them? I've got wiring now that I've got to get down there to that equipment, that pool equipment. So, unless this wiring is necessary to supply pool equipment permitted by this article. So, this is telling me that I can go into that 5 feet if I'm supplying the wiring methods to get down to the necessary pool equipment. One thing I'll remind you that once you get into this 5 foot zone, the depth requirement for that wiring method that gets down to that necessary pool equipment has to be in accordance with 300.5, not 680.10. So what are the cover requirements in 680.10? That leads us to the last paragraph, and that is where it says, okay, so you can't have any wiring in the 5 foot perimeter, but if you got to run some wiring that has to go like branch circuits to the pool equipment, then we'll let you put it in there. You got to meet the depth requirements of 300.5, which is a normal underground raceways and cables and what have you requirement, 300.5 again. But what if you have spatial limitations? Okay, so maybe the pool is close to the house and I can't maintain that 5 feet, but I really got to get it through there. Well, now the code says, look, where spatial limitations prevent wiring from being routed a distance of 5 feet or more from the pool, such wiring shall be permitted where installed in a complete raceway system of rigid metal conduit, intermediate metal conduit, or non-metallic raceway system. Typically, a raceway system, going to be a non-metallic conduit. So, from point A to point B, where the circuit originates to where it terminates, it's got to be in a complete raceway. So you can't run some cables through there and just sleeve them for protection as it moves through that 5 foot area. Okay, it has to be a complete system. If you want to install it in that 5 foot area and you've got spatial limitations, then it needs to be a complete raceway system. Now, of course, all metal conduit that's shall be corrosion resistant and suitable for the location. Means it's got to be rated for the wet location. It's got to be rated for the environment to which it's going to be exposed and what have you. Then and only then that it says the minimum cover depth shall be given in table 680.10. And that's for that wiring that is allowed to be in that 5 foot zone simply due to spatial limitations. Otherwise, you're going to use 300.5. Now, why I think this is correct is because in the 2017, I believe, they're going away from the table and they're going to reference 300.5 because those depths are pretty comparable to what we have here in 680.10, with the exception probably of the non-metallic one here. So I believe it's 4 here, and they got it 6 here, so a little more restrictive up here in 680.10. But again, you got 4-inch slab over top of it. So anyway, I think you'll see in 2017 this table disappear. Could be wrong. I will let y'all wait and find that out. But at any rate, this is what it's talking about. And so this depth right here has to do with those raceways that are being there because of spatial limitations. The 680.12. Maintenance disconnection means you're going to see this referred to in fountains. You're going to see this referred to in spas and hot tubs. You're going to see this a lot. And you need to understand what we're dealing with here. And what it says is, look, for one or more means of simultaneously disconnect, all ungrounded conductors shall be provided for the utilization equipment other than lighting. Okay, so if it's a spa, for example, and I got a 50 amp application, it's 240 volt application, that disconnect needs to simultaneously disconnect those ungrounded conductors. So that's kind of what we're talking about here. Now, each means shall be readily accessible and within sight. And within sight is a defined term in Article 100. Shall be from the equipment and shall be located at least horizontally 5 feet from the inside wall of the pool, spa, fountain, or hot tub, unless it's separated by an from the open water by a permanently installed barrier that provides a 5 foot reach path or greater. In other words, in order to reach around it, it's going to exceed the shortest path required to reach that disconnect. It would be equivalent to being 5 feet. In other words, you can't reach around and get it from sitting in the pool, spa, or hot tub, or what have you. Okay? And Fountain was added in 2014, so you can see that change there. These are all examples of disconnects that could be used. This snap switch right here could be used as a disconnect, provided like for motors or pumps if it's a horsepower rating that's adequate, depending on the size of the motor and what have you. You got a pull-out disconnect which might be able to be used. You got this panel here which is, might be within sight and could serve the purpose. And then of course you have a typical cutout box like this that could serve that purpose. Obviously these are rated for to make sure that it is rated for the location that is to be installed. So the switch would be in an FS wet location box. This looks like a NEMA 3R enclosure. This looks like this has NEMA 3R applications to it. And this might be, I do see some knockouts, but I think this is also a 3R application, might even be more than that. But anyway, this is the disconnection means as well. So all of these could be acceptable depending on the location and where you install them. All right, so let's come on back here to me. All right, so you made it through part 1. Now when we get to part 2, 3, 4, 5, 6, and 7, we might redundantly go back and talk about some of those definitions so we can make sure we understand where we're at. Hopefully you've built on this by watching part 1 series here, and then we'll go to part 2 and part 3 and so on. And that gives you something to build on, because if I do it this way, then you can come back and watch it at a later date and kind of watch whatever part's more important to you. Rather than sit and watch the whole thing, if I have an application where I only need to deal with a hot tub and spa, then I can go and watch the episode on hot tub and spa and not have to watch everything else. But the general requirements I'm going to cover each time so that you kind of make sure that we hammer that home, okay? Hopefully you've enjoyed this presentation. For those that watched our 6-hour seminar, I'm sorry, man, it just didn't record it. Now, hopefully this one recorded. Again, if you have any questions, email me at info@masterthenec. If you want to visit our website, again, that's masterthenec.com, .net, or .org. If you want to participate in our message board, go to Master the NEC and you'll see a link there at the top that you can click on. Join the message board, post your questions. There's no know-it-alls here. I'm no guru. I learn something new every day. I've been lucky and blessed enough to be associated with some great educators in my life, people that I've grown up looking up to, the Mike Holtz, the Tom Henrys, the Jeff Sargents, the Phil Simmons, all of these individuals that I've grown up around, and the Charles Millers. All of these individuals that I've grown up around that have contributed to me learning the code through the years. And you always like to say you walk on the shoulders of giants. So I do. I walk on the shoulders of those individuals, and I am so blessed to know them, be associated with them, and learn from them. And hopefully I can do my little part and pass that on. Okay? So hopefully you've enjoyed that. If you have any questions, email us. Visit our Twitter at MasterTheNEC. Go to our Facebook page, Master the NEC. Go to Facebook and look it up. You can find it. Post your comments. Do all you want to do. Twitter, all that kind of stuff. Listen to our podcasts and wait for some more webinars. And stay tuned for part 2 of Article 680. God bless. Till next time.